Arizona. Bill Boynton, co-investigator and lead scientist for the Thermal and Evolved Gas Analyzer, also known as TIGA, from the University of Arizona. Victoria Hipkin, mission scientist for the meteorological station from the Canadian Space Agency near Montreal, Quebec. And Mark Lemon, co-investigator and lead scientist for the Surface Stereo Imager from Texas A&M University. And we're going to start our panel today with Michael Meyer.
Thank you, Sarah. From 200 million miles away on the bleak, frozen surface of the Martian Arctic, Phoenix Lander has been toiling away for 65 sols. And for its effort, it has tasted success. The mission is going very well, and it's been proving very successful, and Mars has certainly proved itself to be interesting. Mechanically, the spacecraft is operating great, and there's plenty of power margin to carry us beyond the waning summer. So with that, what we'd like to do is announce that we're going to extend the mission to go to the end of the fiscal year, which brings it to like Sol 124. And as a demonstration of how well the mission has been going, the mission has already met the minimum mission success, and we're pretty close to completing full mission success. The orbital resources of Mars Odyssey and the Mars Reconnaissance Orbiter have been doing a great job with synergistic measurements that have not only helped us in terms of telecommunication relays, but in the science itself. They've been able to take local measurements from Phoenix and expand them to the region. And also, the orbital assets, by looking down, and with Phoenix looking up, we've been able to make measurements simultaneously of the same column of the atmosphere. So Phoenix is studying the hydrological cycle and the polar processes, looking at the recent history of the subsurface ice, and then also potentially habitat in the soil-ice interface. And with this, it will really help lay out, do the groundwork for coming missions of like the Mars Science Laboratory in 2009 and also the Scout Aeronomy missions in 2013. But tell us more about recent and exciting progress that Phoenix has gone into. What I'd like to do is now turn to the principal investigator, Peter Smith.
Thank you, Mike. On behalf of the Phoenix mission, we want to thank you for the extended mission. This is important to us. All our instruments are healthy. We are going to complete the science we set out to complete in our prime mission. However, that science is being done in one location on top of one of the little hillocks or mounds that's in front of us. And we have lots more to explore within reach of our robotic arm. So we are planning to extend 2 new trenches, and this is what we'll be doing in this extra time you've given us. And these trenches will go not just from the tops of the mounds in front of us, but down into the troughs in between. This is important. Those troughs are places where material brought in by winds can collect. As you might suspect, it collects in the low spots. And it's places where we see in orbital images that ice persists for the longest period of time, and therefore maybe a place with a different characteristic than those on the hummock. So the extended mission will be a time to explore new parts within reach of our arm. And if I can have the first slide, I'll show you just exactly where these new trench locations are and their names. We've first dug Dodo Goldilocks on the left, and we're currently drawing samples out of Snow White way to the right. And now we're going to work in between. We're going to start with Cupboard. The idea being that maybe the cupboard is full and this is a place to find new discoveries. And we will dig from the top, furthest away from the spacecraft of one of these little mounds or hillocks, all the way down towards the lander, which is in a trough region. And then we'll also look at Neverland in the center. And this is very close to one of the larger rocks within reach of our arm, and a place where we think the ice table underneath the surface may be modified by the presence of a rock. The rocks tend to get a little warmer than the soil. So this is an exciting time, and thank you very much, Mike. The progress to date has been rather dramatic. We have finished, since the last time we've talked, that we finished our complete panorama in full color and in stereoscopic views. So we actually have a topography now of the landscape around us, and Mark Lemon will be showing us examples from this wonderful product. We have a weather station that's operated for 65 sols. Vicki Hipkin is going to be talking about that and what we've learned from our polar weather station. And we are following the NASA guideline of looking for water on Mars, and we expected to find water in this landing site. That's why we came here. Odyssey discovered regional water supplies, but we're very pleased to see that we landed right on top of water ice, and the thrusters spread the soil away and revealed ice right underneath our lander. This was unexpected, and this was a wonderful thing for us because the water could have been all around us and not within reach of our robotic arm. We had no way of knowing on the local scale how the ice was distributed. So this has been a wonderful thing for us to be able to dig a trench, the Dodo Goldilocks trench, and find at 2 inches deep that there's a solid layer, and then to scrape pieces of this white solid layer off and watch them sublimate over the course of 4 days. So that was our first indication that this hard material is definitely ice. We have been now looking at the properties of the soil above ice. This is important for modeling this surface and trying to understand the interaction between the ice and the tiny amount of water vapor that's in the atmosphere. And we use a probe on the end of our robotic arm for trying to understand the physical properties of this soil, which are so important to our models. And that's what we've been doing for the last couple weeks. Plus, we've been looking with our microscope at samples of the soil. We see there's a clay-like component, in other words, very small flower-sized particles. And these particles have unexpected properties, as we found when we tried to scoop some up and deliver it to one of our prime instruments. And we are just getting to the point where we can apply another tool in our toolbox, the atomic force microscope, which takes our resolution down by a factor of 40 over the microscopic pictures that we have shown. And this image, this microscope is just about ready to start its mission, and we'll be using this extended mission to do that sort of science. And so I ask for a little patience here as we get to the part of the mission where we do the scientific analysis of the soil in contact with ice. This does take some time, and we still have not collected all our data, so it's definitely going to take some time. And we are looking to understand the history of the ice by trying to figure out if this ice has ever melted, and through melting has created a liquid environment that modifies soils, changes chemistry, changes the microscopic appearance of these soils. And we're just getting the data back in the last week or two, and even, as you'll find out, very recently, yesterday. So this is an exciting time, and through this analysis we also hope to be able to answer a question that goes beyond just finding water ice, but is this a habitable zone on Mars? A habitable zone meaning that we have periodic liquid water, not today but over time, and we have the materials that are the basic ingredients for life forms. It'll be for a future mission to find if anybody's home in this environment, but we will be finding if this is a place that needs to be searched for life forms throughout the next 2 months of our approved mission. So far we've had 2 wet chemistry analyses completed. We see that the soils are alkaline. This is a mystery. We're on the edge of a volcano. This is typically an acidic environment. Certainly the 2 MER rovers have found lots of evidence for sulfates and acidic environment. We find an alkaline environment here. Perhaps it has something to do with that nearby crater that impacted into this ice-rich soil and spread out a ejecta blanket that we are landed on top of. So that, I don't know for a fact, but that's a possibility. We are also finding nutrients, sodium, potassium, magnesium, chlorides. All of these things are things that we find in our own bodies and are definitely nutrients that are important for life. However, we have yet to discover organic materials. But the important thing is that we have used our Snow White trench to try and get a sample of icy soil into our TIGA instrument. And first we did it by using the blade on our scoop to scrape down to the very hard materials where we could go no further. And then we have a scraper